So thank you very much, and thank you, Nell. Yeah, so, who am I? My name is Nico. Been working on Rust since 2011. I think I'm the longest surviving member of the development team. I've worked on the language design, the compiler implementation, project organization, lots of different things. But I'm here today to talk about project goals, which is what I've been working on the last 6 months or so. So if you follow the RFC repo, you may have seen this RFC go by. It declares a set of 26 project goals, of which 3 are called our flagship goals, covering the remainder of 2024. So about 6 months, because it was accepted in June. And the idea is we're going to repeat this process every 6 months. So we have a kind of 6-month rolling roadmap. And I'm going to go into detail on these specific goals, what they mean for you, for Rust, and why they're important. But before I do that, I want to talk just a little bit about the process by which we got here and why that's important. So if you've been involved in the project a while, you might remember we used to publish annual roadmaps. We stopped in 2021, and this is kind of an attempt to start that process back up, because I don't know about you, but I felt the difference between when we had the roadmaps and now, where we used to have a little more coherence and direction, and then things kind of got harder to follow, harder to tell what's happening, and so forth. But this time, for this version of the process, it's working a little differently. Right? Before, there was kind of top-down, where we would end up with an RFC written. Well, there was a call for blog posts, but at that point, it became kind of top-down with an RFC that was written by some people within the project and then shared and sort of debated. But here, the idea was to do it more bottom-up. So in May, we posted a blog post on Inside Rust, asking for people to submit goal candidates, I should say, to the Rust project goals repository for potential inclusion in the roadmap. Right? And the candidate, or the qualifying criteria to be a goal is, well, first, something you want to see happen over the next 6 months. But secondly, something you want to see happen so badly that you are willing to put your own time, energy, money, some sort of resources towards making it happen. Right? Something you're willing to own and push forward. And you here might be an individual, it could also be a company, it could be different kinds of actors. But this has that old school open source vibe of kind of scratch your own itch, right? So we know that every goal represents something that's at least important to somebody, important enough that somebody wants to put their time and energy into making it happen. Now, that's great, it's good. It's not exactly the bar for being accepted. Being important to somebody is good, but it doesn't make it good for the project overall. So that's why project goals are then confirmed and accepted by the teams, the Rust project teams, that you're asking for resources. So I don't know if you saw Jack Huey's talk yesterday. If so, you'll have some idea what the project teams are. But they're kind of the groups that make decisions about the Rust project, right? And if you don't need anything from a team, then you probably don't need a project goal, right? Then it's like, I'm going to put a crate on Crates.io to do something. Good, you should just do that. You don't need the Rust project's permission. But sometimes it might be, I'm going to experiment. I'd like to build a crate to do this thing. And if it works out well, I think this would be a good inclusion into Rust standard library or into the cargo project or something like that. And I don't actually want to go down this path of building it unless the Rust team agrees that this could be, in the future, if it works well, something for the Rust project to take on. In that case, you are asking for something from the team. It may not be coding support or reviews, but it's like discussion and moral support, right? It's kind of, yeah, I think that's a good idea. We would be up for that if it works. That's actually one of the things you can ask for, discussion and moral support. It's kind of the lowest level. And then it goes up from there, right? You might say, no, we're going to hack on the compiler, and I want to be sure that you'll be reviewing these PRs in a prompt way. Or it might be all the way, for the language design team, I'm going to be rewriting an RFC, and I'd like you to reach a decision on it. Don't leave me hanging. I don't want to put in the work if you're just going to tell me no for sure. It's not worth it. So having these goals lets us kind of set expectations up front. And we saw that in the process, where some people came And teams would sometimes push back and say, we don't know if we're going to be able to do that, and would it be okay if we did a lesser amount of support, and so forth, until we reached a level that everyone sort of agrees on. So I'm pretty excited about that. It's also a way for us to designate things that the project thinks are important, which we never really had. Before, we didn't have a great way to do that up front, and so things would kind of, you would know it's important because you know the people involved and you've talked to them. But that'd be very hard for, say, the foundation, for example, to use as a basis for awarding grants or fellowships. But now with project grants, we've been able to coordinate, and we have a kind of more objective way of saying, yeah, this is something that the project supports because we have a goal towards it. So that's been really cool. Now here's the goals that we actually chose. Like I said, there were 26. And by the way, this talk is online, my repository, RustConf 2024. So if you want to, you can go through and click these links. Uh-oh. Or you could if I turned on my Wi-Fi. I forgot I was planning to do that. Okay, let's do that. What is the name? Could this be it? Hopefully I know the password. Okay, yeah. Is it capitalized? I don't know. This is awesome. Okay. I wish I'd done this on purpose, but I didn't. Let's try again. Woohoo! All right. So one of the things that I'm kind of proud of is, we pulled all this stuff into a website, which is kind of accessible, although I have to update it a little bit. It's a little out of date still, like all websites. But, for each of the goals, if you're kind of curious to learn about it, there's a write-up. They're not very long, which is the goal. There shouldn't be too much work to make. Gives you a summary, a little bit of the motivation, a little bit of why we're doing it, what we're going to do over the next 6 months, that kind of thing. No, and down here you can see here's what you actually need from the team, right? Okay, so enough about that. You can explore that on your own time. Let's talk about the flagship goals themselves. The very first one is the Rust 2024 edition. And a big shout out to Travis Cross and Eric Hoos, neither of whom I think are here, too bad, but they're organizing and doing an amazing job pushing this whole project forward. So what is an edition? If you've used Rust for a while, you probably know, but it's easily misunderstood. So I do want to take a moment to cover it for reference, because we're going to have the Rust 2024 edition. We've had a few in the past. This will be the latest one. And I think it's a really cool part of Rust. And so if you're working on a project like Rust, you're working iteratively, you're releasing things, you're bound once in a while to realize, I'm not sure if I'd call it a mistake, but it sure would have been nice if we'd made a different decision about this particular thing that we released a long time back. Because now, we want to do something a little differently, and it doesn't quite fit together. And usually, you have a couple choices. You can either just say, well, too bad, or you can try to change it. Right? And if you're going to change it, you have to figure out, what are you going to do with the code that's already out there? Right? Now, one thing you could do, the easiest, most obvious thing, is to make a 2.0 release, a breaking change. This is what we don't do. Right? But you might say, all right, we have the 1.x compiler. We've been releasing it till now. We're going to release Rust 2.x, 2.0. And it does not compile the 1.0 crates, but we continue to support 1.0 for a while, so on. And then the problem is now, if I want to go move my crate to 2.0, and I find out that some of my dependencies haven't already moved, I'm kind of stuck. There's nothing I can do about it. And so you end up with this very painful transition where the whole ecosystem has to kind of move over it at once, right? And that's annoying. So what we did instead was something called editions. Today we have Rust 2021, and most things are using it. Probably not Saturday, actually, for various reasons, but that's okay, because it maintains a long compatibility horizon. And then we're going to release a new version of the compiler, which is going to support both Rust 2021, so it still compiles all the old things, and Rust 2024, the newer version of the language with some small changes. And now you can bring your crate over into Rust 2024, and that's just fine, even if your dependencies are still in the old edition, because we still compile that. In fact, it can go the other way too. Your dependency might go to 2024, and you don't, and that's fine, because we have full interoperability. So you get to move at your own pace, right, and upgrade in a convenient when it makes sense for you, not when it makes sense for your dependencies. So that's pretty cool. It's not everything, because this is Rust. We like tools. It's not good enough that you should have to go edit yourself. We'll have the compiler do it for you, right? We really want you to upgrade. We'll try to make it really easy. So you can go check out the edition guide if you don't know about that and learn more. But that's coming. We're going to have it, well, I think the official release will be early next year, but the finalizing later this year. Now, this font is not looking pretty. There we go. So what are we actually changing? Let me give you an example of what we can do with the Rust edition and why I think it's so cool. Here's a function. You may recognize the kind of thing it's doing. It takes in a slice of datums, which I understand is non-grammatical. I just left it here to annoy Tyler Mandry because he really likes when I say data. Anyway, it takes in a slice of datums, and it returns an iterator of processed datums, right? And this impl iterator means I'm not going to tell you exactly what type I'm returning. I'm just telling you it's some kind of iterator, and the compiler is going to infer it from the function body, right? And in this case, it's saying as you iterate, you're going to apply this process method to get a processed datum. So the key thing is you're not actually doing the processing during the function. It's going to happen afterwards as the iteration is taking place. So what happens if I try to compile this? Let's try it. Oh, what's this? Hidden type captures lifetime that does not appear in bounds. Okay, so how many people really understand what that error message means, like in a pretty good level? Okay, for those at home, not too many, though not too bad, but not a whole lot. Okay, let's keep going. Help. To declare that it captures this, you can add, okay, so here's a diff I can apply. That's good. So how many people know how to fix this error on the basis of what the compiler is telling you? Okay, not as many as I would hope there, but still a lot. More than before. That's fine. We're going to do it. We're putting in plus tick underscore. And what do you know? It builds. So this is Rust 2021. What is happening here? Well, what's happening is in this signature, because we're not just telling the caller that we're giving them an iterator. We're telling them also a little more information, what values that iterator might keep using. Which one is it going to use while you're iterating? And in this case, the default is that you won't use any references unless the lifetime of that reference appears in your bounds. So when we say plus tick underscore, or more explicitly here plus tick a, we're actually saying, and I might use values with lifetime tick a. Actually, we're saying more than that. It's enough for now, though, right? And that allows the caller to know that, okay, then I have to be sure that this value is still valid and so forth for the entire duration of the iteration and so on. It's part of how we do memory safety. And that's the default behavior in Rust 2021. But as you can see, it kind of gives this weird error message. It's kind of complicated, and it might not be what you want. When we looked around in code that exists, we actually found it's usually not. Most people do want to return values that make use of the references that they're given. And in fact, it's kind of inconsistent because we have, for example, async functions. We'll say more about them later. That desugars to a function that returns an impl future. At least that's what we tell you. But that's not really true because this future actually captures or uses all of your parameters. Like the first thing it does is store your parameters. So actually, it desugars to something that has a plus tick underscore. And like I'm saying here in this footnote, it's actually something even more than that you can't even type because we didn't have a syntax for it. It was internal to the compiler. And what happens in Rust 2024? Well, thanks to whoever was awesome and implemented this, we can actually find out. Oops, what am I doing? Let's just click. So we can go here. We can switch the edition to 2024. It's not stable yet, but you can use it on nightly. And we can build it. This is the original code, right? No plus tick underscore, no nothing. Hey, it builds. Cool. Why is that? Well, we changed the default. So we changed the default. And now, by default, you can use all the parameters. And there's a syntax, which I won't go into detail on, but you can explicitly name the things you use if that's not what you want. So we could say, hey, I don't use anything. That's right. And then we get the old error back. Oh, good. OK, well, because that's not true. I do use things. But Let's go. So yeah, so that's pretty cool. Actually, I put this in the wrong slide, but I'll just say there's a blog post on the Rust blog that covers all this if you want to learn more about it. But I think this is a good example, right? What does this Rust 2024 goal say about Rust as one of our kind of core values? I think it says we're not done making Rust better, right? And just because we made decisions doesn't mean we can't simplify things and make Rust easier and better to use every time. And so the way I see it is we've seen Rust grow from sort of toy language to powering big systems on the internet. Now we saw with Miguel talking about Rust for Linux, like going into your kernel, kind of covering the span of programming. And you could take from that, hey, I think Rust is kind of done, like it's been really successful. But what I take from it is we have a ton of potential, and that's all the more reason to kind of keep making it better and keep making it more accessible so that all those areas become places where everybody can come and build, right, without wasting their time with memory safety errors and all that. So yeah, let's get some for that. That's cool, right? Yeah. Okay. So what about flagship goal number 2? Bring async Rust and sync Rust closer to parity. So networking is a big area for Rust. I think the survey showed 51%. It might have been 59. I can't remember. But it was a big chunk, more than half, of Rust programmers are building networking applications of one kind or another, right? And why is that? Well, they're a good fit. I mean, one reason, a pretty common one, is Rust doesn't have a garbage collector, so it doesn't have garbage collection pauses. And when you're building something that's running at really high scale, usually you have to decide how much scale to use, how many computers you want to run, based on the worst case. What's the worst thing my customer might experience? The slowest request. So GC pauses are kind of killer there, right? Because that's the worst. So Rust lets you pack more stuff on one machine, run with a smaller fleet. It's good for the environment. It's good for your costs. It's good for everyone. That's cool. But not everyone's running like huge services. A lot of people are just running little functions at a time, hosted on the cloud. Well, Rust is good for that too, because we don't have a runtime. You don't have to run up a JIT. You just get fast performance from the get-go, low memory usage. That's cool. But I think the thing that maybe is most appealing, though, for a lot of people is the emphasis on reliability. Basically, many of these services run 24/7, right? And having compilation errors instead of runtime errors means that you find the bugs like during working hours instead of getting paged when you're at a movie or something like that. And that's a much better time to find a bug, right, when you're in the middle of developing. So these things make Rust a really good fit for networking applications. But despite that, that's why we're getting so many people doing it. But actually, it turns out async Rust, which is kind of the variant of Rust most people use, is sort of Rust on hard mode. Right? This is the quote I heard, and I loved it. It's challenging. And why is it? I mean, it seems easy. Well, you know, you've probably seen async await, either in Rust or elsewhere. It's like, OK, I have a function that might make network requests, so I write async. When I call it, I write await. What's so hard about that? Well, nothing. The problem is you can't actually do that everywhere. Right? We only support that, well, until pretty recently, we only supported it in a small subset of where you might want it. Last year, we stabilized async function and traits. This year, we're going to stabilize, I hope, async closures. They work on nightly already. And then we'll keep going. Right? We've got to get through this list. And at that point, async Rust starts to become something that feels a lot more like sync Rust and like that original sort of just add async and await, and you're done. So let me talk about async closures real fast. You've probably heard of closures. They're kind of callbacks, right? So in Rust, it typically looks like this. You have a function like for each prime that takes an impl fn, so some type that implements the fn trait, function trait. You can call it. On the other side, you put these parallel bars, and that sort of declares a closure that's going to get called for 2, 3, 5, and so on. So what does it look like in async land? I mean, today you can't. In stable Rust, it doesn't look like anything, because you kind of can't do it. It's very hard. There are ways you can kind of do it, but they usually work. But if you use nightly Rust, and what will hopefully be stable soon, it looks like this. You write well, first you have an async function, and then instead of impl fn, it's impl async fn. I want to note here that this syntax is not stable. We're still deliberating. We might change it. But it'll be something like this. Could be capital async, capital fn. Anyway. And then you, because it's an async function, when you call it, you get back a future, so you await it. And on the other side, you write an async closure, right? So it has that feeling of, yeah, I put a bunch of async keywords, and every time I might do network access, I put in await, and we're good to go. I want to note, we're seeking feedback on this. We haven't gotten much, which I think means it works perfectly. That's what I'm taking from it. So if you think you might have an issue, you should go try it out and let us know. So what does this say about Rust? I mean, fearless concurrency for the win, right? Like this is one of Rust's core value props, being able to scale way up. Scaling up means parallel and concurrency. That's the way it happens. And we're continuing to work on it and make that story more true. All right, our final flagship goal, bringing Linux kernel closer, not all the way, takes more than 6 months, to building unstable Rust. Right? And we've got a bunch of people working on this goal. I want to give a particular shout out to Ding Zhengfei and Alice Ryle, who've really jumped in and taken on a number of tasks. But I mean, we heard from Miguel this morning, so we kind of get the basic idea of Rust for Linux. You know, we're going to use Rust in probably the most demanding possible low-level environment, which is really cool, kernels. But what I like best about it, they could have just gone and used unsafe Rust. You actually I've heard from people who do this, who say to me, look, we use a lot of unsafe. Frankly, it's just C++ to us with a better syntax. And okay, I mean, they're getting something. I'm glad they're using Rust. But it's not like the full value, right? But building safe abstractions and letting you actually do the majority of your work in safe Rust, that's what Rust for Linux is going for. And that's the real multiplier. That means that they can now have people come in who actually don't necessarily yet, at least, have the deep sort of systems wizard knowledge of all those unsafe details, and they don't have to be productive and bang out a kernel module that kind of does what they have to do, and then they can learn more as they go, right? And I think that's really cool because, well, the way I see it is this. We call it systems programming wizards, right? People who know this deep esoteric knowledge, but they're not, it's not that they're special in some way, it's that they didn't have anything better to do but learn that stuff. But like many people do, right? They're trying to get business done or do something else with their lives besides like reading operating system manuals. And so that's okay. That's also a good choice. And I want them to be able to come and be productive at however they want and go as deep as they want eventually, right? And open that door to as many programmers as we can. So cool. That's great. What's the problem? Well, to build those unsafe abstractions, they have to use a lot of unstable features that go into the deep, dirty details of Rust that we haven't really stabilized. And so, part of that is we didn't have a really great customer for them to help us like use them and validate that the design was really going to work. So now we do, and that's awesome. And we're working through it. It also makes it a lot better for the people. Interestingly, like in some sense, the prime audience of this is the people who want to work on the Linux kernel in C. Because those people don't want to use nightly Rust. They don't even want to know that Rust is there. They're working on their C code. They just want to know that whatever Rust compiler is in their Debian distribution works. And unfortunately, right now, they can't do that. They have to track exactly the right version that works with exactly the right semantics. And so if we can get it unstable, they can stop thinking about Rust until they're ready to go give it a try and be delighted by its many surprises instead of out of anger because they have to download some obscure toolchain, right? That's much better. So what does it say about Rust? No limits, We're going to go all the way down as small as you can get, all the way up to the cloud. It's going to be awesome. And we're going to make it safe all the way across. Pretty cool. Pretty cool. So big shout out to the Rust for Linux contributors. This is the full list. Y'all are doing good work. And the last thing I'm going to say is another part of being an owner. I said you have to be willing to do the work if you want to propose a project goal. That's step one. You also had one other thing you have to do I didn't mention. You have to be willing to write an update on what you've done, which is much, much harder. That's like pulling teeth sometimes to get people to do that. But that means that we can then write blog posts and talk about those things and see the progress we're making and also know sometimes, hey, we're actually not making progress on this goal. And that's not a problem. We don't expect to do all these goals. But sometimes it means someone's stuck and we have a chance to help them, right? And that would be good. So I plan to get started on the first update next week. I'm kind of committing to getting it done. That's probably unwise, but I'll do my best. So yeah, we'll see how that goes. And I just want to leave you with this. This is kind of where I see Rust going. We're getting simpler and simpler. We're getting more and more concurrent, and we're breaking the limits on how low we can go. So let's keep it up. Thanks, everybody.